Hello and welcome to this intro. In this video, we're going to walk through what a blockchain is and develop an intuition for it using this visual tool. You don't need any prior background for this. Broadly, there are two common ways blockchains agree on new blocks: proof of work and proof of stake. Proof of work is about mining and heavy computation, which you might be aware of. Proof of stake works differently. It's based on ownership or what you call stake. This visualization focuses entirely on proof of stake. Let's start with the most basic building block, a hash. You can think of a hash like a digital fingerprint. I type something here and I get this fixed looking output. Let's try writing something here. And if we change it, the hash changes too. What's important isn't what the hash looks like, but how it behaves. If I change even one character, the hash completely changes. Let's add just a space to the input. There, the entire hash is different. This sensitivity to change is what makes hashes so useful. Now let's move on to a block. A block groups some data, the previous block's hash, and something called a proposer. In proof of stake systems, we usually talk about validators. A validator is just a participant allowed to create blocks. The proposer is the validator who gets picked to create the next block. For now, let's assume there are two validators with equal stake, 50 and 50, so no one has any advantage yet. Once a validator proposes a block, the block gets a hash, which basically locks everything inside it. So, what exactly is stake? In proof of stake, validators lock up some value in the system. That locked value is their stake. You can think of stake as influence in the system and also responsibility. The more stake a validator has, the more likely they are to be selected. Basically, collateral damage. As I move these sliders, you can see the probabilities change in real time. Even with higher stake, selection is still probabilistic, not guaranteed. Stake alone isn't enough though. If the system always picked the biggest stakeholder in a predictable way, it would be easy to exploit. That's where randomness comes in. This randomness is driven by something called a seed. A seed is basically an input value that helps generate unpredictable but still verifiable outcomes. Each time we run this, you can see that the seed changes. This randomness is combined with stake to choose a proposer. So selection is weighted but not predictable, which is exactly what you want. Now when we jump back to the block view, this ties together. Let's validate a block here. A validator gets selected using stake and randomness. They propose a block and the block is hashed. Great. Now, every blockchain has a starting point called the genesis block. The genesis block defines the initial validators and how much stake they start with. There's no previous block here. This is literally where the chain begins. Everything that comes after depends on this setup. Finally, let's look at the blockchain itself. A blockchain is just a sequence of blocks where each block stores the hash of one before it. Let's add some blocks here. There. Now notice, if I add blocks normally, the chain stays valid. But if I go back and tamper with a block, let's type something here, the entire chain from that point onward becomes invalid. That's the core security idea behind blockchains. Data is easy to verify, but really hard to change. So, a quick recap. Hashes detect change, validators propose blocks, stake affects selection, randomness keeps things fair, and blocks link together into a chain. Playing around with a visualization like this makes these ideas way easier to understand than just reading about them.